So this video is going to cover section 7.3 in Algebra 1. So let's go ahead and get started here. First thing I want you to do is to try these two warm-up questions. You'll notice it's the same system, but one is going to ask you to solve by graphing and one by substitution. So you should get the same answer each way. Pause the video, and then when you come back, we'll go ahead and do those together. So on this first one, we're going to go and graph both of these lines. I'm going to do a little color coding here. So this first equation, y equals x plus 1, we're going to graph that. Our y-intercept is 1, and then our slope is 1. So it's going to be a rise of 1 and a run of 1. And we will draw our line. And then we'll go to the second equation. And this time our y-intercept is 3. And we've got a slope of -1. So I'll go down 1 over 1 and draw that line. And then you'll see that they cross right here at 1, 2, which is our solution. So this one, fairly easy equations to solve with graphing. We can also solve this one by using substitution. So for substitution, if I take this x plus 1, and since it is equal to y, I can substitute it in for y right there. I get the equation x plus 1 equals -x plus 3. And then I'm going to solve that equation for x. I'll start by adding x to both sides to get it so that all the variables are on one side. That'll make a 0 there. Bring down my 3. X plus x is 2x plus 1. And now I can solve this equation by subtracting 1 from both sides. 2x equals 2. Divide by 2, so x equals 1. And then I'll plug it back into this equation, so y equals x plus 1. Well, if x is 1, it's going to say y equals 1 plus 1, which of course is 2. And then I'll write my coordinates 1, 2. So you can see we get the same exact equation same exact solution both times. It doesn't matter which method we use, we need to get the same solution. The last thing we'll do here before we start with our new method is adding and subtracting vertically. We're going to do this a lot with this new method called elimination, so we need to practice that. 2 plus 4, 6. Feel free to pause the video and kind of go on ahead here if you'd like. 5x minus 3x is 2x. 3x minus 3x just gives us 0. -3 plus 5 gives us 2. 2y minus 3y is -y. -1y, but we don't write the 1. 8y minus 3y is 5y. 5x minus x is 4x. And 4y minus 4y gives us 0. So when we're subtracting or adding variables up and down, we're still just combining like terms. So here's what we're going to do. Today we're going to talk about solving systems by using vertical addition and subtraction, basically adding one equation to another. And you'll notice something. These first two examples are specifically picked out to do one thing here. And you'll see that in a second. It's called the elimination method for a reason. What you have to notice first is that all the like terms are lined up vertically. X's with X's, Y's with Y's, ones or numbers with numbers, and the equal signs are in the same place. If that is not true, that's the first thing we're going to have to fix. And those are more of the advanced questions at this level. You'll worry about those more in later math classes. So all we're going to do is just add vertically the like terms. A -2x plus a 2x gives me 0. Y plus y gives me 2y. And 1 plus 5 gives me 6. And this is the reason why we call this elimination, because what you'll notice here is that the x variables eliminated each other. They were a 0 pair, and they make 0, so that's gone. There is no more x term, which makes a really easy equation to solve for y. I need to get rid of that 2 by dividing by 2, so y equals 3. Then we'll need to go back and solve for the other variable. I can use either equation. In this case, I'm just going to pick the one that doesn't have any negative signs in it. So 2x plus y equals 5. And all I'm going to do is replace that y with 3, because I know that y is 3. Then I can solve the equation just like any other equation. -3 minus 3. 2x equals 2. Divide by 2, and x equals 1. So I have the solution 1, 3. So when one of those variables cancels out, that leaves us with just one extra variable to solve, and that's pretty easy to solve. Now, going back and finding the other variable is usually going to be a little bit harder with this method than it would be with substitution, but finding the first variable was quite a bit easier. So it's a little bit of a trade-off. Some systems are going to work really well with substitutions. Some are going to work better with elimination. And it's kind of for you to decide which one sometimes. Okay, next one here, we're going to do the exact same thing. We're going to add the two equations together. Y plus y makes 2y. 2x minus 2x makes 0. 1 plus 3 makes 4. And so I don't need that 0 in there. I have the equation 2y equals 4. Well, I can divide by 2 on both sides and get y equals 2. That's not so bad. That step's pretty easy. Now to find my other variable, in this case the x, I am going to take one of these equations. Let's just use the first one since there's no negatives in there. It might make it a little bit easier. And I'm going to just replace the y with a 2. And that is the equation I have to solve. So I'll subtract 1, 1 equals 2x, and then divide by 2, x equals 1/2. Right, fractions are okay, right? Big thing I want you looking at here is don't focus on what's over here on this side. Focus on what you're trying to get rid of. That'll tell you the steps to take. So putting my x and y in as a coordinate pair gives me 1/2 comma 2. Okay, so we'll flip to the back here and let's just talk about what we did. The elimination works when we have a variable that forms a 0 pair. So if we have 4x and negative 4x, 2x and negative 2x, that's when elimination is going to work. Now, if we don't have that 0 pair, we need to create one. Adding two equations together when there's not a 0 pair is not going to eliminate a variable. We are going to create one. And the way we're going to do that is by multiplying one of the equations for now, just one of the equations, by a number. And so when we do that, this is just the distributive property. If I multiply the equation by 2, I'm just distributing the 2 to all the terms in the equation on both sides of the equal sign. So I'd have 2x, negative 2y, and equals 2. If I'm multiplying by negative 1, well, then I distribute that. Negative 1 times x is negative x. Negative 1 times negative y is actually a positive y. And negative 1 times 1 is a negative 1. So we can multiply equations like that. Usually we think about multiplying both sides separately, but we're really just multiplying the whole equation by the same number. So let's take a look at our last two. On these two, we're going to have to multiply one of the equations. You can see if I just added these together, nothing would cancel out, nothing would eliminate. So what I'm going to do is multiply equation 2 by 2. And you'll see what happens when I do that. 2 times x is 2x, 2 times y is 2y, 2 times 1 is 2. And I always like to go ahead and just copy that other equation down so I have them right next to each other. Some people don't do that, but I like to. Then we will add them together, which is our elimination step. And because we multiplied the second equation by 2, I've created that 0 pair. 2x and negative 2x makes 0. 2y and y makes 3y. 2 and 1 makes 3. Now I can solve by dividing by 3, and I get y equals 1. Then I can pick any of the equations I have to solve for x. I'm going to pick this x plus y equals 1. Just going to pick the one that looks like it's going to be the simplest. And I'm going to replace the y. Since y is 1, I'm going to replace the y with 1. Subtract 1, x equals 0. And so my final solution is 0, 1. And let's go ahead and do the last one here. You can always pause the video if you need to kind of slow them down. This time, they're not telling you which one to multiply by, so I want you to think about this. Which equation would you multiply, and by what? Think about it for a second. Okay, so most people get the idea that we should definitely multiply this second equation. So we're going to multiply equation 2, just because it's going to be easier to match the bigger numbers by multiplying. Now we have a choice here in what we multiply by. The easiest solution for most people is probably to multiply by 3 because that's going to give me a 3y, which will cancel out with a negative 3. I could also multiply by negative 2 because that would give me a negative 2x to cancel out with the x. I'm going to go ahead and stick with the positive 3 because that's just a little bit easier for our first time doing this. And we'll multiply through by the 3, and that'll give us 3x plus 3y equals 3. And I can bring down my other equation, 2x minus 3y equals 12, and we can add them together. 3x plus 2x is 5x. 3y minus 3y is 0, and 3 plus 12 is 15. That goes away, and I can solve my equation by dividing by 5. X equals 3. So I solve for x. Now I've got to solve for y. I'm going to use this second equation again. So x plus y equals 1. I know x equals 3. So 3 plus y equals 1. And I am subtracting 3 from both sides to get y equals negative 2. Which means my final equation here, final solution is 3, negative 2. The last thing we're going to talk about here is our special systems. So some things that can happen when you add up equations. Let's do this one. Negative x plus x, 0. 2y minus 2y, 0. 1 plus 3, 4. So we've got the equation right now, 0 equals 4. That is a false statement. And if you remember back to any of the other equations we've solved, if we get a false statement, that means we have no solutions. Solutions. Now, just as a quick reminder, if I ever end up with a equation like 3 equals 3 or 0 equals 0, that is a always true statement. Well, in that case, now we have infinite solutions. In other words, it doesn't matter what x and y is. It's always going to be true. So there we go. Make sure you're trying the proficiency practice and then the CFU.